This video will look at 5 techniques for solving quadratics of the form ax squared plus bx plus c. 3 that you can do algebraically without a calculator, and 2 using the TI Inspire. Okay, the first technique is solving by factorizing. Now when we do this, we have to make sure that it's equal to 0. Remember, the form that we're trying to solve is ax squared plus bx plus c equals 0. Making it equal to 0 allows us to apply the null factor law, which states that if a times b is 0, then a is 0 or b is 0. So to get that equal to 0, I am adding 11x to both sides and subtracting 3. To factorize that, I need two numbers that multiply together to give a times c, which is negative 12, and they have to also add to get 11. Those numbers are 12 and negative 1. That tells me how I'm going to split that middle term. It's going to become 4x squared plus 12x minus x minus 3. Then we're going to factorize by grouping. Group the first two terms together and bring out the common factor of 4x. Group the next two terms together. They're both negative, and so we can bring out a common factor of negative 1. Bring out the common factor of x plus 3, and then apply the null factor law. So x plus 3 is 0, or 4x minus 1 is 0. So solving those two linear factors gives us x equals to negative 3, or x equals a quarter. The second technique involves solving by completing the square. So to complete the square, the easiest way to do that, I believe, is to get it in this form. So we've got ax squared plus bx equal to a constant, and then we make this the perfect square. So to do that, I'm going to begin by subtracting 3x from both sides, 6 from both sides, giving me x squared take 3x equals 1. This is what I'm now going to make a perfect square, and to do that, I'm going to add half of the b value, which would be negative 3 over 2, squared to the left-hand side, and then I must also do it to the right-hand side. On the left, you're best off keeping it as negative 3 over 2 all squared. On the right, we can do the square. To keep it on the left makes it easier to see that it's just x minus 3 over 2 all squared. And on the right, 1 plus 9 over 4 is 13 over 4. So now we have this perfect square. We're going to take the positive and negative square root of both sides. You must remember to do that, because if we square a negative solution, that will still give us a positive answer. And we're going to add 3 over 2 to both sides. Simplify that third. Root 13. Square root of 4 is 2, and when I add those together, just to tidy it up, I can put it as a single numerator. The third technique is really useful because it works for every quadratic, and the quadratic formula is basically a generalization of completing the square. and it is x equals negative b plus or minus square root of b squared, take 4ac, all over 2a. In this quadratic, a is equal to 3, b is equal to negative 2, and c is equal to negative 7. And so we're now going to substitute into the quadratic formula. X is negative b plus or minus the square root of b, don't forget brackets here, it's important, squared minus 4 times a times c, all over 2 times a. Tidying up the numerator gives us positive 2, negative of a negative, plus or minus the square root of 4 minus negative 84, so plus 84, divided by 6. 2 plus or minus the square root of 88 over 6. Okay, and we now have root 88, which can be simplified to 2 root 22 over 6. And then there's a common factor of 2 in each of those terms, so we can simplify that to 1 plus or minus root 22 over 3. The next technique involves using a feature on your GDC called polyroots. So that's the function we're going to solve. So if we go to the calculator, and if you go Menu, Algebra, Polynomial Tools, and find roots of polynomial, a quadratic, the highest power is squared, so for a quadratic, the degree is 2. Click OK. Now you'll see this form, which should look very familiar to you. The calculator just uses A2 in place of A, A1 in place of B, and A0 in place of C. So you can see that we need to have it equal to 0. So if we go back to our quadratic, to get that, we're going to have to subtract 8.2 from both sides. Okay, and then this is A2, this is A1, this is A0. Alright, so we go to our GDC, we've got 5, we've got negative 0.6 and negative 8.2. Hit OK and it brings this up. Okay, the quadratic, this comma x means we're solving in terms of x. Hit enter and there's our two solutions, which you would give to 3 significant figures. Negative 1.22 or x is approximately equal to 1.34. Note that we have rounded, so you should be using approximately equals and not equal to. The final technique we can use is graphing, and this has the benefit of not having to be rearranged into the form ax squared plus bx plus c equals 0. All we're going to do is graph the left-hand side as one function, graph the right-hand side as another, and then we're going to find the points of intersection. Which your calculator can very easily do. So if we go back to our GDC, and now we want a graphing page. Oops. And on the left-hand side, we've got 8x minus 2x squared. There's our graph. Okay, it's a quadratic. That shape is called a parabola. And then press Tab and type in the right-hand side, which was 7. you'll see that it intersects in two places. So if we go Menu, Analyze Graph, Intersection, and see how it's asking you for the lower bound? That just means click this dotted line somewhere below, so to the left, of the point of intersection you want to find there. Now it's asking for an upper bound, and you see as soon as I move it to the right, it locates the first point of intersection. So this is one of our x values. X is approximately 1.29. Yeah, now going to repeat to find the other one. Menu, Analyze Graph, Intersection. It's asking for a lower bound. Put it somewhere between the 2 points of intersection. You don't want to put it down here because then it will look for the first one. You want to put it here and then the upper bound somewhere above. Click Enter, and there's our second solution.